Okay, so I hope everybody's doing all right today. Just a few quick ideas again before we go ahead and get started. If you were needing a waiver for this class or possibly another upper level or weighted class, deadline is Friday by 10 a.m. Mr. Young's secretary, Marcia Edwards, will help you take care of that. Don't forget, tomorrow we have that tornado drill. 9:15, so during second period. If we were to have a tornado drill in here, is everybody aware of where we would go? Okay, so that art office corner right there on the main hallway. Good. We're going to have our quiz tomorrow, the first of the 6 weeks on the inverse homework we turned in yesterday, our most current lesson. You will be allowed to use your notes. This one you will be working individually. Okay, so you can use your notes or anything else that you may have. The first exam is coming up a week from Monday, so about a week and a half away on October 8th, so we'll be looking ahead to that. It'll definitely have some trig on there, probably even go ahead and throw some factoring problems on there to see how you do. And let's go ahead and get on with our focus activity. Now, last week, we got the first one, which I should still have copies over there in the filing cabinet by Adolfo, if anybody needs one. But last week, I believe Miss Stone worked that with you. She was talking about absolute value inequalities. And this is the focus activity she did with you last week, and she brought up the little rhyme, more is or, less is nest. And it was kind of unusual. A lot of people are like, what does less is nest mean? We haven't had the ability to look at it until now. But if you're solving an absolute value inequality, if it's greater than, we focus on the phrase more is or. Okay, and this is our strategy. We take the inequality and we write it as is. See, 3x minus 12 greater than or equal to 6. Or, because greater than is more and more is or, there was two things I did for the second inequality. I reversed the symbol and then did what? I changed the sign. Okay, the 6 went to negative 6. So this is what you want to do if you're solving an absolute value greater than inequality. More is or. Okay, well, what does less is nest mean? Okay, so how are these two problems on our focus activity today different from the ones we were just looking at? They are less than. Okay, so we're not doing the more is or strategy. We're going to do that less is nest. And neither myself nor Miss Stone came up with this rhyme. It's something I'd heard before. It is silly, but it can help you remember. So here's what it means. I've got the absolute value of 3x plus 4 less than 10. So I'm going to write the inequality exactly as I said. 3x plus 4 is less than 10. And it doesn't matter if it's less than or equal to. If it's a less than, you're going to use the same strategy. Okay. Well, when it says nest, what it's referring to is what we call a compound inequality. So while I'm less than 10, I'm also going to be greater than negative 10. Okay. At the beginning of the expression, I'm going to put the same symbol and take the opposite of my constant. So we're kind of nesting the expression between the constant and its negative version. Okay. I don't know if I would have come up with that analogy personally. If it helps you, fantastic, or if you just want to remember what to do. But that's it. This is what we call a compound inequality. Now, think of the rhyme for just a second. More is or. Well, what word did or use when we were talking about sets? Remember, that was the union, okay? So less is nest. This refers to an intersection. This is and. So there are two inequalities here. Negative 10 less than 3x plus 4 and 3x plus 4 less than 10. We looked at one of these at the very beginning of the school year, and I believe we separated it and solved them independently. But this time, why don't we just go ahead and leave them together? When you're solving an equation or an inequality, whatever you do to one side, what? Yeah, you got to do the same thing to the other. You have to maintain that balance, right? So here, I'm trying to get x all by itself. So whatever I do to the middle, I'm going to do to both the right and the left sides. Okay, so what would be the first step? Subtract the 4. Okay, I want to get 3x by itself. So if I subtract 4 from the middle, I'm going to subtract 4 from the other two sides. Basically, I'm solving both inequalities together. Okay, so these opposites are going to cancel. I have 3x in the middle. See, the symbols just come right down with it. Negative 10 minus 4, negative 14. And the 10 minus 4 will give me 6. Okay. Where did the other? Oh, that's from the opposite. Because when you're thinking about this big picture, whatever value of x makes this true, well, its absolute value has to be less than 10 units away from 0 on the number line. So if we're going to go 10 units in one direction and that can work, well, we also have to be able to go 10 units in the other direction. Because like, for example, if I'm at 0 on the number line, okay, and I have 10 here, well, anything between 0 and 10 is going to be true, right? So that same distance, I should be able to go in the other direction, negative 10. So like negative 1, negative 2, negative 3, okay? Those are going to be values that would work here with the distance. So that's the same idea, okay? If I can be 10 away from 0, I should also be able to be negative 10 away from 0. So we just take the opposite, okay? And what's my last step here? Oh, yes, Ross. Then there'd be no solution. There'd be no solution. Because remember, absolute value will always give you what? Always give you a positive, and a positive will not be less than a negative number. But that's a good question. I'm glad somebody brought that up. Okay. So, yeah. So if you ever run across like an absolute value equation, like if I had the absolute value of 3x plus 4 equal to negative 10. Doesn't matter if it's equal to, less than. If we're looking at a negative constant, no answer. Nothing's going to make it work. Okay, so what's my last step here? Divide by 3. There we go. So divide by 3. So I've got x in the middle. Negative 14 thirds, I'll just leave that as an improper fraction. Is less than x, which is less than 2. There we go. So only the values of x between these boundaries are going to make this a true statement. And remember, last week she spoke to you about showing these graphically and as an interval notation. So I'm going to put negative 14 thirds and 2 on here. Open or closed? Open, because we don't have equality. So open circle. And remember, your graph should mimic what your expression looks like. I want every value between these two. So I'm going to go ahead and shade between. Okay. And I know that my interval notation, the lower boundary, negative 14 thirds, the upper would be 2. But how am I going to cap that? Parentheses or brackets? Parentheses, because we will not include those. If I were to plug, say, for example, 2 in, it should give me a false statement. It should not work. Okay, so more is or, less is nest. You want the best, go to the west. I'm a poet and I didn't know it. I'll stop. Okay, all right. Moving on. All right. So number 2, now with this idea in mind, I want the absolute value of 6r minus 3 less than or equal to 21. Okay, so what expression should I write? Negative 21. That's it. Okay, whatever expression you have, you're going to put it between its positive constant and its negative, and you're going to keep the same symbol. Okay, according to the rhyme, we nest it. I don't know. Okay. I kind of think that's for the birds, but I don't know. Get it? Because birds nest. No? Sometimes with the jokes, I just try to wing it. Maybe it works out. So, okay, moving on. So how would I solve this one? What do I do first? Add 3. So let's say I'm going to add 3. So I'm going to add it to all 3 parts of this compound inequality. So let's see, what's a negative 21 plus 3? Okay, so negative 18 is less than or equal to 6r, which is less than or equal to 24. Okay. And now we divide by 6. So I heard negative 3, 4. There we go. Okay. So I'm going to represent my answers in 2 other ways. Graphically, here's negative 3, here's 4, but the circles this time will be closed. Okay, again, I want all values of r between those two. So I'm going to shade between. I know that -3 is my lower boundary, 4 is the upper. But how would I close this time? Brackets, because they are included. If I plugged, whoa, that was weird. If I plugged in either -3 or 4, it should make it a true statement, unlike the previous one. All right. Does this kind of seem familiar? I think you probably would have seen that maybe Algebra 1, maybe Algebra 2, depending on your teacher. Does that kind of look familiar? A little bit? Okay. If not, does it make sense? Okay. All right, well, good. You have 2 focus activities. I actually have the third one ready to go for Friday. So we'll put these up. And what we want to go ahead and do now is go back and just keep talking a little bit about factoring. Okay, so I want to go ahead and practice a little more today. I do want to take about the last probably 10 minutes of class to go ahead and give you just a little in-class assignment that you guys can work on together, just a little bit of factoring practice. So I'm hoping we get to the grouping today. If not, I could probably turn it into a focus activity or just at some other point later on. But yesterday we got to talking about a couple of different strategies, one of which was just a GCF. What does that mean? Greatest common factor. That is the first step if you're going to factor anything. And remember, this packet right here, I did give this out last week. If you have misplaced or lost it, I do have extra copies right over there in the filing cabinet. So let's go ahead and run through a few of these, again, just to make sure that we're good to go. And yesterday we were just kind of picking and choosing which ones we liked. How about, let's say 7. Okay, so 7. 10x squared y minus 15xy squared. Okay, so maybe it helps just to go ahead and start with the values and look at the variables. What do 10 and 15 share? 5. They're both divisible by 5. Okay, so I'm going to pull out a 5. Now, I know no matter what happens, I'm still going to be left with a binomial. So I'm going to go ahead and put parentheses here. I'm going to put the minus in the middle. But I've left a little bit of room between the 5 and the parentheses because I know I'm going to be pulling something else out. They have x squared y and xy squared. We can pull out an x and a y. First off, every term has to have the same variable. But pull out the variable with the smallest power. That's what's going to be common. So I can pull out an xy. Okay. And let's figure out, what would I multiply a 5xy times to give me 10x squared y? It would simply be 2x. And remember, we were talking about this yesterday. If you ever get stuck, if you don't know what your term in your expression needs to be, take what you need. We needed to have a 10x squared y divided by your GCF. Okay? And it will always help you out. We know that 10/5 will give me the 2. We've got 2 x's over 1, so a pair of x's can cancel. And then the y's cancel. And see there, we've got our 2x. What's the other one got to be? It's just going to be 3y. There we go. Okay, so there's the greatest common factor. Okay, just like on the assignment today, maybe there is or is not a GCF. Maybe the GCF is the only thing I can do to factor it. Okay, and then after this, we went ahead and we're looking at difference of squares. Okay, when you factor those, you get the a plus b, a minus b groups that we called conjugates. Okay, so let's go ahead and choose one of these. How about number 7? Let's do number 7 again, lucky number 7. 9x squared minus 1. Again, we always want to double check, is there a GCF? No, besides 1, I mean, there's nothing that divides both of these, so we can skip that. All right. So they are 2 perfect squares. I am subtracting them. So I'm going to go ahead and get my groups ready. 1 plus, 1 minus. Let's see, what's the square root of 9x squared? 3x, right? So I'm going to put 3x, and what's the square root of 1? 1. Okay. Now, one of these I had listed as prime. Like, for example, let's look at 15. 25 plus 4x squared. Can I factor that one? Okay, I can. So I could say 5 plus 2x and 5 minus 2x. On this one, I can't. But why? 25 and 4x squared are perfect squares. Nope, not a variable. You have to have subtraction. Yes. Okay. The fact that it's being added makes all the difference. So that one I can't do anything with. Okay. Now, if it was 25 minus 4x squared, absolutely I'd be able to do something with that. Okay. Let's try number 14. 2x squared minus 8. Okay. First off, is there a GCF? Yes, 2. Okay, so I'm going to pull out the 2. Bring down this minus here. So what's 2x squared divided by 2? X squared. And then minus what? 4, because 2 times 4 would give me 8, right? Now, we were able to pull out a GCF here, but let's take a look at what's left. Is there any way I could factor that again? There you go. X squared minus 4 is a difference of squares, yes. So this guy here, just as Nathaniel said, x plus 2, x minus 2, and I'm forgetting something. Yeah, don't forget about that 2 we originally pulled out. Okay. Okay. What do you think of that, Genevieve? What do you think of that, Genevieve? What do you think of that, Genevieve? Yeah, she's asleep, yeah. How you doing, Genevieve? How you doing there, ma'am? Okay. All right, let's get her head up, please. Thank you. All right. Math was just so exciting, she couldn't take it and just passed out. Okay. What's up? 2x plus 4, x plus 2. Now you said 2x plus 4, x plus 2. Now 2x plus 4, x minus 2 would still be equivalent. You'd have to have one positive and one negative still. But in that case, even though it's still equivalent, we would say it's not completely simplified. Even if there's something as simple as a GCF, we always want to go ahead and pull that out. Okay. We want it to be broken down into its prime components. Okay. Little Bill? Because of the plus, yes, that's exactly right. Okay. That was difference of squares. And then there was another idea we spent some time on yesterday. What does my father drive? A red Mercedes convertible. In reality, my dad actually drives a maroon Ford pickup, but that has nothing to do with what we're doing here. But it's like, please excuse my dear Aunt Sally, the first letter of every word is a step in the process. Okay. Multiply, factor, divide, reduce, move, and check. And this is where, we finished up yesterday. So let me choose some problems here. And, for some of these, you don't always have to go ahead and use this process. And like I said yesterday, if you already have a strategy, a way to factor trinomials, please continue to use it. It's whatever you like. If you like this method, great. Okay. Like these right here, do you remember what we called it if it started with a coefficient of 1? Another word for easy. Simple. We called those simple. So maybe on these, you don't need to run through that process. Like this right here. Number 1. What 2 numbers would multiply to give me 8, but then also add to give me 6? Yeah. 4 times 2 is 8, but 4 plus 2 is 6. So this would be x plus 4, x plus 2. Okay. Well, what about 4 right here? X squared minus 10x plus 16. 2 numbers that will multiply to give me 16, but they have to add to give me negative 10. So let's think. Here, both of my signs would have to be the same. They'd either have to both be negative or both be positive. How would we know which? Okay, check the middle. See, I got to multiply to get a positive, but I have to add to get a negative. So that's already telling me it's got to be a minus minus. The only way it's going to be a minus plus is if your constant is negative itself, like number 11, where it has the negative 32. So what 2 numbers will multiply to give me 16, but add to give me 10? 8 and 2, yeah. So on some of these ones that we refer to as simple, maybe you just think about it. Okay, but the process that I'm about to show you again will still work. Let's choose some of these here. Okay. Let's just go ahead and look at some of these randomly, like number 10. Let's do number 10. Okay. 4y squared minus 20y plus 25. Now remember, the first step, always look for a what? Always look for a GCF. Is there anything that divides 4, 20, and 25? No. So there's no GCF, so let's run through that process. 4y squared minus 20y plus 25. Okay. So the first thing I'm going to do is multiply. I'm going to multiply the first coefficient by the constant. So 4 times 25 will give me 100. Now this is where we factor. We've done the first step where we multiplied. I need to find two numbers that'll multiply to give me a positive 100, but when I add them, I should get a negative 20. So what do we know about the signs of my numbers? It would have to both be negative. Okay. Okay. Negative 2 and what? 50? Oh, negative 10. Oh, I'm sorry. I thought you said negative 2. So let's see. Negative 10 times negative 10. Will that work? Yeah. Negative 10 times negative 10 is a 100. Negative 10 plus negative 10, there's your negative 20. That right there is the hardest part of the entire process. Okay. You just need to find two numbers that'll work. But if you do, the rest of it, you pretty much guaranteed yourself you're going to get it right. What do I divide by? Because that's what the D stands for. 4. I always divide by the leading coefficient. So I'm going to say 4. 4. Okay. And then the R? Reduce. So what is a negative 10 fourths? Negative 5 halves. Negative 5 halves. And now, our last step is to simply move these numbers to create our groups. So here's my question. We're dealing with y. Would this be negative 5y plus 2 or 2y minus 5? 2y minus 5. We always, always, always start in the denominator and work our way up. 2y minus 5. Now this type of trinomial has a specific name. If both of your groups end up being the same, we call that a perfect square trinomial. Okay. Doesn't make any difference in the long run, but there you go. Let's try another one of these. How about one of these down here? Well, let me skip these for just a moment. Let's choose some better ones. Those are all simple ones. Let's try... Hey, let's try 16. That one looks pretty good. Okay. 3x squared plus 21xy. So we're on section 7, number 16, the one that says hint check for the GCF. Minus 54y squared. Okay. So it gives us a hint, but the first thing we would do anyway is check for that. What divides all three of those terms? 3. Now, can I pull out an x or a y? No, it comes close. The last term doesn't have an x, and the first term doesn't have a y. So they're not all common. All right, so I'm going to pull out the 3. Let's see. So I'm going to bring down my plus. I'm going to bring down the minus. What would the first term be? Just x squared. Now, I know the next one would be xy. It would be 7. Okay. And then minus what? It would be 18. 18y squared. Okay. All right. Now, the fact that it has both an x squared x and a y squared y, don't let that bother you at all. Okay? Just imagine it's a normal trinomial. We're still going to run through the whole process. Okay? So I'm going to multiply the first number by the last. In this case, we don't have a constant, so it's just going to be the last coefficient. So what's 1 times negative 18? Negative 18. Okay. Now, because this one's negative, I already know whatever two numbers I'm going to choose, right, Rhett? Okay. One's negative, one's positive. But whatever numbers I choose, they have to add and give me what? They got to add to give me 7. Well, what do we think? Okay, 9 and 2. And the 2 would have to be negative. There we go. But let me ask you a question. Will negative 9 times 2 still give me negative 18? So why won't that work? There you go. If I were to add these, that would give me a negative 7. Okay, so where you put your signs are going to be really important. Okay, so what am I going to divide by? 1. That's the new leading coefficient because remember, we already took care of the 3. We pulled him out as a GCF. We're just focused on what's left. So I'm going to divide by 1. Now, here's what we do normally. I'm going to go ahead and get my groups ready. I'm going to go ahead and even put the 3 out in front so we don't forget. Okay. Now, normally, this right here, negative 2 over 1, well, that would be 1x minus 2, right? But what was different about this problem? There's a y. If there happens to be a second variable, then you just go ahead and hook it to the numerator. Okay? Because x, our first variable, always gets hooked to the denominator. Okay? So normally 9 over 1 would just be x plus 9, but what's it going to be here? X plus 9y, that's it. And boom, we have our factored version. Okay. How we doing? Is this coming back to you? Okay. Remembering the good old days of Algebra 2 and everything? Yes, okay. Well, let's take a look. I do want to go ahead and show you, let's see, the grouping. All right, let me go ahead and show you the grouping very quickly. I didn't put any grouping on the assignment today, just with the idea that we may not reach it, and I didn't want to rush it, okay? But here's the idea. Like, let's take a look at number 1, and there's one already worked out here for you. X squared plus 2x plus xy plus 2y. So this is at the very end. This is section 12, factoring by grouping. Well, you want to use grouping if you have 4 terms, okay? Well, look at all 4. Is there a GCF? Something that divides all 4 of them? No, not in this case. So it is possible to have a GCF for all 4 terms and still be able to use this method. But this one does not. So x squared plus 2x plus xy plus 2y. Okay. So here's how grouping works. Always look for a GCF first, right? Okay. But if there's not one, what you want to do is group the terms into smaller ones. So I'm going to take the first 2, and I'm just going to put parentheses around them. I'm going to group them. Okay. Then I'm going to take the last 2 terms, and I'm going to put them in parentheses. Plus, so I'm going to say xy plus 2y. Okay. Here's the only thing you need to remember when doing grouping. You must always add the 2 groups. Always add. And I'll show you a different one in just a second. But see, here's the idea. If there's not a greatest common factor for all 4, maybe I can make smaller groups and get a GCF out of those. What divides both x squared and 2x? X. So I do have a GCF for this one. So what would that leave me? X plus 2, right? Okay, plus, is there a common factor for x, y, and 2y? Yeah, see, I can pull out a y, which would leave me x plus 2. Well, do you notice anything? They're exactly the same. If this can be factored, that's exactly what you should be seeing. You know, if I had, like this here, just this binomial, you see I was able to pull out the y, and I was left with the x plus 2? That's exactly what we're going to do here. Instead of pulling out just a single factor, got a text message. Instead of pulling out just a single factor, we're going to pull out a group factor. Okay? So the group that repeats what's common, I'm going to go ahead and write that first. And then the GCFs I pulled out, I combine those into a second group after it, x plus y. That's grouping. Okay? So if I were to multiply those 2 binomials together, I'm going to get that 4-term polynomial we started with. Okay. You guys have seen this one before, right? Dear God. Okay. I'll check it in just a second. All right, let me try another one that has a negative. Let's try number 9. And this will be our last example for today. Okay. In fact, I'll tell you what, because it's already 24, let me go ahead and stop there. Probably tomorrow, before we go ahead and start the trig, I'll just go ahead and do another one of these or two to make sure you feel comfortable. Okay. But I did not put any grouping on this one. All right. So here is the paper. Okay. And this is not a quiz, so you guys can work together. You can use your notes. Okay. The only stipulation is that you can't ask me a question. Okay. So I'm giving you 5 factoring problems. So these are going to cover GCF, the difference of squares, and the trinomials. The my father method we were just looking at. Okay. Want to make sure. Oops. Andrea, there you go. Here we go. Well, these will separate. That would be great. There you go, sir. Okay. All right, so this is going to be our first actual daily grade of the 6 weeks. So if you go ahead, make sure to turn this in before you take off. Okay. Remember, take these opportunities, help each other out. Maybe one of your classmates can explain something better than I can. Okay. I mean, I'm just an old man, right? I'm glad nobody agreed with me. Thank you very much.